Hi, this is Shrey Derasari,
And I'm Mayank Shouche.
and this is our show where we answer your science questions in an exciting and simple way that even a 5th grader can understand.
Recently, we were asked by our many viewers to explain the phenomena of a magnifying glass.
So today, we are going to answer the question,
Why do magnifying glasses make objects look?
Before answering this question, we must address the fundamentals of lenses and their interesting properties.
So, most lenses we see in everyday life are what we call converging lenses.
These types of lenses cause light that comes into them to converge at a certain point behind them, such as
Glasses,
contacts,
cameras.
and even our eyes.
So, light from around us enters our eye through a lens, just like any other lens in glasses or contacts.
This light, because the lens in your eye is a converging lens, focuses on your retina, allowing you to see all around yourself.
This lens, just like any other lens, has something called a focal point.
Actually, two. One in the front and one behind.
Wait, but what is a focal point?
Well, a focal point is a certain distance from a lens where rays of light meet after being reflected or refracted from the lens itself.
Also, the images that lenses form depend on where the object is in relation to this focal point.
In a converging lens, putting an object between the focal point and the lens makes a virtual image, where the image is on the same side as the object and in most cases makes it bigger.
Oh yeah, just like a magnifying glass.
But what about when it's far away from the focal point?
Well, that makes it a real image, where the image is on the opposite side of the lens.
In order to quantify this, some very intelligent scientists came up with something called the lens equation.
It describes many of the lenses that we see every day and looks like this. 1 over di plus 1 over do equals 1 over f.
This may look complicated, but it's not bad at all.
In fact, each term stands for some very basic distances that anyone can calculate.
This di stands for the distance between the image and the lens,
The do is the distance between the object and the lens.
and f is the focal length, which we talked about earlier.
You can use this equation to figure out where an image made by a lens will be, or even to find the focal point of a lens.
But sometimes, using this lens equation is a little bit difficult or tedious.
Instead, there's a simpler method that we can use called ray diagrams.
Now, in a ray diagram, you draw a couple of rays of light coming out from an object, and then see how they interact with the lens.
Wherever these rays intersect is the place where the image of the object forms. The image that you see from the ray diagram can also tell you if the image will be larger or smaller relative to the object.
So, now it's time for us to show you an example of a ray diagram being made.
In this ray diagram, you can see that the object is outside the focal point. Let's see what happens.
Now, the first ray of light we will draw is one coming from the top of the object and parallel to the principal axis, otherwise known as the midline of the lens.
Any rays of light that go into a lens parallel to the principal axis come out through the focal point on the other side, as you can see.
The second ray goes through the focal point and then exits the lens parallel to the principal axis.
When a ray of light goes to the center of the lens, it stays on the path it was on before because it doesn't refract.
So now you can see that all the rays intersect at a point on the other side of the lens.
If we draw an image here, we can see that it is real, inverted, and larger.
But what would a ray diagram for a magnifying glass look like?
Well, let's draw one.
So, when you use a magnifying glass correctly, the object should always be inside the focal length.
A ray going parallel to the principal axis, as we saw before, goes out to the focal point and enters your eye.
Another ray, this time going through the center, keeps going on its path into your eye.
As you can see, the rays don't intersect on the right side of the lens like before, but actually on the left side because of reflections inside the lens.
This makes the image appear behind the lens and larger than the object, while not being inversed.
So, the image is virtual, enlarged, and upright.
So that is how a magnifying glass makes objects look bigger.
Thanks for watching!